Hello, and welcome to another Algebra 2 lesson, brought to you by Party Dog Wrapping Paper, presented by Mr. Thompson. So we're going to be going over lesson 11-1. So go ahead, open Canvas, get it open, log in. Should have already done that. Lesson 11-1. Yes, the lesson. Yes, 11-1. Go there. Once you're there, make sure you clicked it. Make sure you hit Start Quiz. Make sure you open the assignment. Now, you should already be there. So if you don't have paper out, you should have paper out. But I mean, I'm going to go over it pretty clearly here. So here's your notes. Feel free to take a picture of this, or you can just come back to the video as needed. Yes, my handwriting's awful. If you don't understand something, listen, and I will go over everything I've written, so hopefully that'll clear it up. But again, like always, if there's any confusion, you can always email me, okay? Alright, so lesson 11-1, the notes. Before we go into this problem, or this lesson, you guys need to understand a few things. I'll go over some new terms and stuff, and the difference between recursive and explicit, as well as like patterns and stuff. So let's get started. Now, patterns can use adding, subtracting, multiplying, or dividing. Okay, you're all super familiar with this, even if you don't think you are. Think of about an even pattern. 2, 4, 6, 8, 10. What are you doing? Adding by 2. Okay. What are we doing with the multiplication one? Well, 1, 2, 4, 8, 16, 32. Multiplying by 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Right? Now notice you can always go backwards. 10 minus 2 is 8. 8 minus 2 is 6. 6 minus 2. 32 divided by 2. 16 divided by 2. So they go forwards and backwards. You can use all 4 of those. Okay, that's important for like the first problem. Now, the rest of these, you're going to have these new terms. This is called a sub n. Okay, so you don't have to really care too much about the terminology here. Just don't get scared when you see this on your homework. So what does a sub n mean? A sub n stands for a term in a sequence. So a sub n is just whatever term you're trying to find in that sequence. So if we look at the example, 2, 4, 6, 8, 10, a sub 1 would be 2. The first term in the sequence is 2. The second term in the sequence is 4. The fifth term in the sequence, 1, 2, 3, 4, 5, is 10. So it just stands for, hey, what term are you looking for in the sequence? And then you convert it to the answer. Okay, you're also going to see a sub n minus 1 and a sub n plus 1. So if a sub n is just the nth term, that's what they say on the gray box or on the textbook and stuff. A sub n, or just the term you're looking at in the sequence, this would be the one after that. This would be the one before that. So if I'm looking for, let's look at this. If we look at this example, if I'm looking at a sub 3, the third term in the sequence, the third term is 6. A sub n minus 1, or 3 minus 1, would be the second term, so 4. The term after 6 would be 8. So it just helps you figure out the terms around the one you're looking at. Okay, super important for recursive formulas. Okay, but we'll get into that later. Now, recursive versus explicit. I know you guys are like, Thompson, did you misspell explicit? And yes, I did misspell explicit, but luckily I just turned it into the correct spelling, hopefully. So recursive and explicit, it sounds a lot more difficult and it looks a lot more difficult than it actually is, but it is hard to understand on your own. So do not feel bad if you read through this lesson before this video and you were just absolutely confused. Okay, that is absolutely okay. I'm hoping to clear that up now. Recursive, the primary thing with recursive formulas, you need the previous term in order to get the next term. So I need the term prior in order to get this. If I wanted to know the sixth term in this sequence, I need the fifth term. Okay, so that's what recursive is. some little keys here for you guys to know the difference. If the formula includes a sub n inside of the formula, it's recursive. So if it says a sub n equals and then it has one of these three things in it, it's going to be recursive. Okay? Explicit. You do not need a previous term to get your any of the terms. So these ones are cool as math can be, I guess. These ones are cool because I can just say, hey, give me the 30th term. And you don't have to go 1, 2, 3, 4, 5, 6, and all the way to 30 to get there. You can, you don't need to. You can just type in 30 for n and solve. So again, the difference here is after a sub n equals, you just have a normal big N, not a little sub n, right? So that's how you'll know it's explicit. You can explicitly substitute in a number for n and get the term you're after. So if I wanted the 20th term in this series, I would plug in 20 and solve and instantly get it. Very easy, very cool. I like those ones. Okay, so hopefully this makes sense. We're gonna come back to it as needed, okay? But right now, let's look at problem number 1. Okay, so as we look at problem number 1, it asks us to find, it gives us two-part problem, right? It gives us the first series, which is 27, 34, 41, and 48. And it says, what's the pattern? And find the next three terms. So the pattern is adding 7. So what you click in that box, the pattern is add 7. Okay, but why? What is the difference between these two numbers? How did you get from 27 to 34? You added 7, right? Now, if you figure that out, you have to test it on all of them. I added 7 to get from 27 to 34. Can I add 7 to get to 41? Yes. Can I add 7 to get to 48? Yes. Now, how do I find the next three terms? Add 7, get 55. Add 7 to 55, get 62. Now, how do I find that third term? You guessed it. Take 62 and add 7 to it. So 62 plus 7 is 69. So, same thing with part B. They give us a new one. Notice it's going down. This one was adding. This one is not. So 243 to 81. I wouldn't know that right off the bat. I wouldn't know what the pattern is, right? But look at 27 to 9. That one's easier. How do you get from 27 to 9? It's obviously getting smaller, so we're either going to divide or subtract. So I'm going to say divide. What are we dividing by? 3. And here's how you check. Go backwards. If you like multiplication, go this way. 9 times what is 27? 27 times that is 81? Yes. 9 times 3. So we're going to write the answer so we don't get confused. Divide 3, right? If we're working backwards, we're going to multiply. 9 times 3 is 27. 27 times 3 is 81. So that should follow 81 divided by 3 is 27. 27 divided by 3 is 9. I hope I over-explained that. So now, the next three terms. If I take 9 and I divide it by 3, what do I get? 3. If I take 3 and divide it by 3, I get 1. Now, don't be too scared about this. What is 1 divided by 3? Well, just write it out. 1 divided by 3. Oh, cool. It's just 1/3. Done. If you get a fraction, it's okay. It's absolutely fine. If I wanted to find the fourth term, it's not required. Just those three are. If I wanted to find the fourth term, I would just divide by 3 again. When I divide by 3, when I divide fractions, I flip and multiply. So I would have 1/9. So again, I say mess with this. Just see if you can get from here to here. Okay, and if you can't, message me or, I'll explain this further if I need to. But just try to see if you can match my numbers. All right, moving on to number 2. It gives us a real-world connection problem about a basketball. And so you really are supposed to look at the gray box. I know you guys like to skip it, okay? But you really are supposed to look at the gray box. What the gray box says is you have a basketball and you drop that basketball. And every time it bounces, you're going to get about 85% of its original bounce from the previous one. So if you drop it at 10 feet, what is it going to be? What is the height going to be after the first bounce? Well, you take it and you times it by 0.85 or 85% and you get 8.5. So if you look at the gray box, they give you the first bounce, the second bounce, the third bounce, and the fourth bounce values. Okay, so if I want to find the fifth bounce, how do I do that? Well, here's the recursive formula. Okay, so they give it to you in the gray box below, but I sneakily wrote it up here for you guys. What does this mean? If I want a sub n, I need to times 0.85 by a sub n minus 1. Sounds complicated. If I plug in 5 for n, what's 5 minus 1? 4. So if I want the fifth term in the series, I do 80.85 times the fourth term in the series. What was the fourth term in the series? 5.220. So I take 0.85 and I times it by 5.220 and I get the fifth term in the series, right? How do I get the sixth term in the series? I take 0.85 and I times it by the fifth term, the one previous, the term before, right? I times that by 0.85. What do I get? 3.77, 145. So again, this is a perfect example of recursive. Why? Because if I want the seventh term, I need the sixth term. If I want the sixth term, I need the fifth term. If I want the fifth term, I need the fourth term, and so on and so forth. I can't just skip ahead and find a random term. So how do I get these? I just multiply each one by 0.85 to get the next one. So if I want the seventh term, I'm going to take 0.85 and I'm going to multiply it by the previous term, a sub 6. What was the previous term? 3.77, 145. Now, bringing out my handy dandy calculator, if I take 0.85 and I times it by, press the wrong button. So 0.85 times 3.77145, I get 3.205735. So 3.2, just round it, 3.2 feet. And that is going to be your answer for the first part of number 2. It says, what is the height after the seventh bounce? Well, we found it, 3.2. How do we find it? We times 85% to the previous term. How do we find the previous term? Times 85% to the term before that, and so on and so forth. Okay? So then part B says, hey, what bounce will it be less than 2 feet then? So after what bounce is it going to be less than 2 feet? So we have 10 feet, 8 feet, 7, 6, 5, 4, 3, 3. I want it to be under 2 feet. So all we have to do is we keep timesing this by 0.85. So I take this times 0.85, 2.7. Is 2.7 less than 2 feet? No. So then times it by 0.85 again. 2.3. Is 2.3 less than 2 feet? No. So then multiply it again by 0.85. 1.97. Is this less than 2 feet? Yes. So what bounce will it be less than 2 feet? The 10th one. The 10th bounce. Boom. All right, so I hope that was pretty clear. Again, this is a great example of recursive, okay? You're gonna need to apply the same formula over and over and over again until you get the terms that you want, okay? And I hope I made it clear that these while looking complicated, is actually just direct substitution. It's not very difficult to do. All right, moving on to question number 3. Question number 3, it goes all into recursive formulas, okay? And then it says, it gives you a pattern in the gray box that you guys usually skip. It says, hey, your pattern is 2, 4, 6, 8, and 10. So we're back to the adding 2 formula. So it says a sub 1 is 2. And then it gives you this formula. It says in the gray box, a sub n equals a sub n minus 1 plus 2, where a sub 1 is 2. Okay, so do we agree with that? If I want a sub 3, I need the a sub 2 and add 2 to it. So if I want the third term, I need to know what the second term is, and I need to add 2 to it. So that's really what it's saying. It's saying, hey, whatever number you plug in for n is going to be the term 1, 2, 3, 4, and 5. So you need the one before it, so you can add 2 to it. Okay? So again, it lists the pattern. So if this is a sub 1, this is going to be a sub 2, a sub 3, a sub 4, and a sub 5. So it gives you all of those. So I wrote a little chart here. A sub 1 is 2, a sub 2 is 4, a sub 3 is 6, a sub 4 is 8, a sub 5 is 10. Now, can you just add 2 and get to these? Yes, that is what you're doing, okay? Even if you don't think you're using the recursive formula, by adding 2 over and over again, you are using the formula. So if I know this is 10, is the next one going to be 12? Yes. Is the next one going to be 14? Yes. How do we prove that, though? How do we show that? Well, if I want the 6th term, I need the 5th term, and I need to add 2 to it. What is our 5th term? 10. So I plug that in directly for a sub 5. And then I add 2, and I get 12. Right? And you do the same thing over and over and over. So if I want the 8th term, I need the 7th term and add 2. If I want the 9th term, I add 2 to the 8th term. If I want the 10th term, I add 2 to the 9th term. So it's very clear. You guys have done this before, you guys just don't know you've done it. So what's the 11th term? Well, take the 10th term and add 2. That simple. Right? So again, take the 11th, if I want the 11th term, I take the 10th term and add 2 to it. You're using the same formula, right? So now I want to find a sub 15, right? So again, here's number 3. Here's the answer to number 3. Now we need the answer to number 4, a sub 15. Well, if 11 is 22, a sub 12 would be 24, a sub 13 would be 26, a sub 14 would be 28, and a sub 15 would be 30. So this one's cool because you can kind of do it in your head, but really you're just doing the formula over and over and over and over. You did the formula 15 times. That's really what you're doing. That's how you find the recursive formulas. Okay, so I hope that was clear, breaking down the recursive stuff. Recursive is my least favorite just because it's so repetitive. You have to do it so many times, right? Explicit, which we're going to be using next, is much easier because you can just plug in numbers for n and solve. Okay, so on number 5 is a little tricky. So if you tried to go through it and you got lost, I understand. So it really wants you to read all of the instructions and go through that gray box. So if you're reading the instructions, it gives you this real world spreadsheet, and it talks about the lengths of sides of this like box and the perimeter of each box. Okay, and then it goes into a recursive formula for, or explicit formula for the perimeters. Okay, we're not going to deal with that. If you go down to number 5, it says write the first 6 terms in the sequence, 1, 2, 3, 4, 5, 6, for the areas of the square, and that's the key word. So the directions are really subtle but very important. Area of the square. So what do we need to remember? how do we find the area of a square? Length times width. And since it's a square, length and width are equal. So we can just say side times side. So I put x times x or x squared just as an example here, okay? Just to refresh your memory of the area of a square, okay? So I took the portion of that spreadsheet that we need, because again, what do we need to find the area? Just the sides. So here's the length of the sides of the first 6 boxes. So if this is the length of the side for the first box, we would have 1 and 1. So if I want to find the area of this first box, I do 1 times 1. And I would get 1. Move on to this one. If this is the sides of the box, I get 2 and 2. So 2 times 2 is 4. If this is the sides of the box, I multiply it by itself. 3 times 3. 4 times 4. Whoops. I'm writing things without even thinking. 3 times 3, 9. 4 times 4, 16. Again, if 5 is the length of the side, 5 is the length of the base, 5 times 5 would be 25. And then finally, 6 times 6 is 36. So I want you guys to see what we did. What term is this? This would be a sub 1, a sub 2, a sub 3, a sub 4. So what is n on all of these? N is just the number of the term we want. N is just the term that we want. The first term is 1, second term is 2, third term is 3. Really cool, very easy. Okay, and what did we do? We took whatever number was in the box and we multiplied it by itself. So the 6th box, we multiplied 6 times 6. So now if we had the 20th box, our sides, if we follow this pattern, the next one would be 7 times 7, 8 times 8, 9 times 9, 10 times 10, 20 times 20. So 20 times 20 is 400. So the area would be 400. So I hope this was really clear. We're going to have to write the explicit formula for this, for number 6. So again, I grouped these two together. So what did we learn from this pattern, right? What exactly did we learn? And spoiler, this is the key right here. We times each of these by themselves, didn't we? 1 times 1, 2 times 2, 3 times 3, 4 times 4, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 20 times 20, 21 times 21, 22 times 22, right? If we kept going, we keep going. What if I had some arbitrary term that I didn't know? Well, what do we call something we don't know? A variable, right? So if I said, hey, what's a to the x? What's the term a to the x? You would say, well, it's just going to be x times x, right? Length times width, or side times side, a to the x. Now, you guys are familiar with the x's. We're just substituting out n for x. So if I say, hey, what's the nth term, right? You would say n times n, just like you did all of these. So n times n can be written as n squared. So the difficulty comes from each one of these problems being unique. Every single pattern is going to have a unique formula for it. So it's not always going to be n squared. You have to find the pattern, and you have to really ask yourself, hey, what is this pattern? What actually am I doing to this pattern? Am I squaring it? Am I square rooting it? Am I squaring it and then adding to? Like, you have to find what the pattern is before you can write it. But n is just standing for the variable you don't know. So again, this is a complex concept, so if you're a little bit lost, that's absolutely fine. I hope you understood these specific problems, okay? I will go ahead and bring the notes back up for you guys so that you can either take a picture or, pause the video, come back to this video as needed. But feel free to email me any of your questions if you're stuck, or you can always join me every Tuesday from 10 to 12 on the live tutoring and get help that way. These ones are, I really like these. They cause you to actually think and use logic, but they are time consuming and they can be difficult. So I hope you enjoyed the lesson. Another wonderful Party Dog lesson brought to you by Mr. Thompson. I hope to see you next time. Have a great day.